First we studied semiconductor, then we discussed what are different types of doping, N-type and P-type. After that, we discussed P-N junction, which is designed by doping the different regions of parent semiconductor material with different dopants. In P-N junction, we have two layers of differently doped regions. A BJT is its continuation, as BJT consists of three layers. In this course, we are going to study the devices up to 3 layers only. However, obviously, more layers are also possible, like thyristor, which have 4 layers of alternately doped N and P region. But that is not in our syllabus. However, its application is in the syllabus of power electronics, which is an important subject of electrical engineering. Anyways, let's have a general introduction of what is a BJT. At first, what does BJT stand for? Its full form is bipolar junction transistor. Bipolar junction here refers to the fact that in BJT, both electrons and holes, irrespective of which are majority and minority carriers, takes part in current flow through the junction. However, in MOSFET, only one type of charge carriers takes part in current flow. The word transistor comes from two words, transfer plus resistor. Transistor is an electronic device used to amplify or switch electrical signals. For a transistor to operate, the minimum number of terminals required is 3. BJT is a type of transistor, very similar to the way PN junction is a type of diode. As I already told, we have 3 layers of alternately doped P, N and regions. Let's consider PNP type BJT. These 3 alternately doped regions are having differences in the doping concentration and in width. The 3 regions are named emitter, base and collector. These names have their history why they are called so, which you will understand in the subsequent lectures. For now, you should know what are their general characteristics. Base is kept very thin in width, whereas collector is usually very broad. Emitter is highly doped, represented by P++. Collector is moderately doped, represented by P+, whereas base is lightly doped, represented by N. The length of different regions is in the order. Collector is usually kept broad to maintain overheat of the BJT by dissipating heat to the surroundings. And the order of doping for a practical transistor is base is lightly doped, whereas emitter is heavily doped. You may think why this is so. Why doping of emitter is very high? Why base width is small? You will find answer of all these questions through the subsequent lectures. However, one important point is we keep this representation of BJT just for easier understanding, but practically the BJT's construction somewhat looks like this. All the 3 terminals lie on the same surface. This is helpful in integrated construction, where a large number of BJTs and other components are constructed on a small piece of silicon. Terminals on the same surface area also reduces the semiconductor resistance. But for understanding the working of BJT, this representation of BJT will work better. Here we have symbols for PNP and NPN type BJT. The junction between emitter and base is represented by JE, whereas the junction between collector and base is referred as JC. Obviously, there are 2 depletion regions. Based on how these depletion regions are biased, the BJT is said to be operating in different regions. We will consider all the possible cases. The possible cases of biasing of the 2 junctions are represented along with the common names to represent the configuration in which the BJT is being used, along with their most important application. Saturation region and cutoff region together bring the application of BJT as a switch. Saturation is the on state of the switch, whereas cutoff is the off state. The first case in which the emitter junction is reverse biased and collector junction is forward biased is called reverse active. This works as an attenuator, but practically it is rarely used. The fourth case in which the emitter junction is forward biased and the collector junction is reverse biased is the most important configuration of the BJT, as the application of amplifier is the most important application of BJT, and we will be looking deep into how BJT is used as an amplifier. That's all for this lecture.